Hello everyone, welcome to today's class, Organic Spectroscopic Analysis. In this chapter, we are going to learn a new spectroscopic technique, NMR. NMR is the abbreviation of nuclear magnetic resonance. The absorption of electromagnetic radiation of a specific frequency by an atomic nucleus that is placed in a strong magnetic field, used especially in the study of the structures of organic compounds. Nuclear magnetic resonance was first described and measured in the molecular beam by Rabi in 1938, and in 1944, Rabi was awarded the Nobel Prize in Physics for this work. In 1946, Felix Bloch and Edward Miles Purcell expanded the technique for use of the liquids and solids, for which they shared the Nobel Prize in Physics in 1952. Purcell had worked on the development of radon during the Second World War at the Massachusetts Institute of Technology Radiation Laboratory. His work during that project on the production and the detection of radio frequency power and on the absorption of such RF power by matter laid the background for Rabi's discovery of NMR. Different atomic nuclei within a molecule resonate at different frequencies for the same magnetic field strengths. The observation of such magnetic resonance frequencies of the nuclei present in a molecule allows the trained user to discover essential chemical and structural information about the molecule. Richard Ernst won the Nobel Prize in Chemistry in 1991 for its contribution to the development of high-resolution nuclear magnetic resonance spectroscopy, which is Fourier transform NMR. The polarized nuclear magnetics of the nuclei begin to spin together, creating a radio frequency signal that is observable. However, they ultimately lose alignment and simultaneously decay to the equilibrium state in the magnetic of having a net polarization vector that aligns with the field. This time-dependent pattern can be converted into a frequency-dependent pattern of nuclear resonances using a mathematical function known as Fourier transformation, revealing the nuclear magnetic resonance spectrum. Kurt Woolrich receiving the Nobel Prize in Chemistry in 2002 for the structure determination of biomolecules like DNA and proteins by NMR. Paul Loutberg and Peter Mansfield shared the 2003 Nobel Prize for their discoveries in the field of magnetic resonance imaging, MRI. Magnetic resonance imaging uses strong magnetic fields and radio waves. MRI collects and correlates signals caused by atoms, primarily water in human body, into images. Using MRI technology, physicians are increasingly able to make diagnosis of a serious pathology earlier, and earlier diagnosis often translates to a more favorable outcome for the patients. MRI tests offer relatively sharp pictures and allow physicians to see internal body structure with great detail. NMR is one of the most powerful analytical tools currently available to an organic chemist. NMR allows characterization of a very small amount of sample from 5 to 10 milligram and does not destroy the sample, so it's a non-destructive technique. Typically, NMR is used in conjunction with other types of spectroscopy and chemical analysis to fully confirm a complicated molecule structure. Let's start from the proton NMR or hydrogen NMR. Proton NMR can tell us what? Firstly, how many types of hydrogens, indicated by how many groups of signals there are in the spectrum. Secondly, what type of hydrogens, indicated by the chemical shift of each group. And how many hydrogens of each type are there, indicated by the integration relative area of the signal for each group. What's the connectivity? Look at the coupling patterns. This tells you what's next to each group. What can be obtained in proton NMR spectrum? First of all, the number of signals. Secondly, the position of signals and the intensity of the signals. The splitting of signals. Okay, that's today's lecture. Thank you for watching. Goodbye.